Okay, welcome back. So we were here talking about the earlier equation. So here Q dot divided by Q equals minus 1 over epsilon C dot T divided by CT, and that's equal to that. So we have, let me use this space, C dot T divided by CT equals epsilon alpha KT alpha minus 1 minus M plus rho. Okay. So this equation, and there are many different forms of it depending on the model, is called the Euler equation. All right. It basically tells me how, on the optimal path, I can manage the growth rate of consumption. Okay. And as we discussed before, this equation is originating from the cost-state equation, and cost-state equation tells me that I basically let the value of the capital stock depreciate once I realize these profits. These rewards. Here, reward is for utility, obviously, right? When I talk reward here, I basically mean the utility I obtain by using the accumulated stock of capital, transforming this accumulated stock of capital to production, and then consuming that output. Okay. Again, there will be many different versions, and if you think about this a little bit more carefully, what we are studying here is a social planar equilibrium, right? This is not competitive equilibrium. There is only one decision maker, and that decision maker takes the decision for everybody else in the economy. So usually we call this as a centralized or social planar equilibrium. Okay. Conversely, when we let people to take their decisions themselves, we call it decentralized or competitive. Okay. Now, if you imagine the very same model and the competitive version of it, what do you have? Well, you once again, the objective, you may imagine that there are people in this economy. So these are, let's say, households. Okay. Now, these households are accumulating wealth. Here, A is the stock of wealth, their assets. Okay. Now, that accumulation will be depending on the interest income they're obtaining for their accumulated assets. And then they have, of course, consumption once again. Okay. So this is the household side, and households are starting with some initial wealth stock. And then there is the firm behavior. Now, firms in the economy, you may imagine that there are many different firms. Okay. Now, these firms have production functions. Okay. Now, this production function is Cobb-Douglas. All right. And firms will have some demand. Here, alpha is again between 0 and 1. Now, these firms will have some demand for capital stock, and that capital stock will be owned by the households through these accumulated assets, right? So the profit of the firm J would be written in this way. So as you see, we already normalized the price of consumption to 1, right? So what we can write here is basically production minus the cost, okay? And here we assume that depreciation is 0, all right? We can add depreciation to the model, and we can let the firms pay for the depreciation, all right? But we are not just doing that for simplicity. Now, obviously, this profit is now profit function is written in this way, right? So if firms solve this problem, the interest rate will be equal to the marginal productivity of the capital stock for each firm. But here firms are identical, right? So each firm will choose the very same demand for capital. Okay. Now that demand for each T. Now this is now a general equilibrium model, right? It's now a dynamic general equilibrium model. We have the household side. Households will solve their Hamiltonian problem. Firms will solve the static problem, and then this will be their decision rule. And then at the end, we will have market clearing. Here we have only one market. So in that market, this is the asset market. In that market, the demand for funds will be equal to the supply of funds. Okay. Now, if you look at the situation in this way, the earlier equation will feature what? The earlier equation will be written in this way. If this is again Ct 1 minus epsilon divided by 1 minus epsilon, then you will have epsilon times RT minus rho plus N. Okay, so even further, you can, since this is the growth rate of the economy, you may write just this, and this is the expression you find for the earlier equation. Okay, because this is again the marginal productivity of capital originating from here. Okay, now I just showed you two different versions. Obviously, one is the central planner solution or the social planner solution. In that solution, there is no market at all. There is this president or the benevolent dictator, whatever you want to call it, the central planning office. So they take decisions for the entire economy by maximizing the same utility function so that they are benevolent. They take these decisions, or he or she takes this decision only for the benefit of the households in the economy. So people's preferences are still taken into account. And then there is this competitive version. In the competitive version, markets are operating. There is no decisions taken in a central planning office. There is no president, nothing. So everybody will behave according to his or her own interest. So firms will maximize profits, households will maximize utilities, and then in the asset market they're gonna exchange these assets. So firms will have some demand for funds, and those funds will be supplied by the households. There will be a market interest rate that reflects the marginal productivity of capital, and then households will plan accordingly. There's of course this other market that we disregard because of the Walras law, right? So there is also this market. Okay, but this one of the markets, as you know, is cleared by the Walras law. So we choose the price of one of the goods. Here we choose the price of consumption goods to be equal to 1. So we basically count every single allocation here in terms of the final good. So when I talk about an interest rate, I basically say of course, 3%, but it is 3% on the final good units. Okay, when I say, okay, I will pay you the interest that is equal to 3%, it means I will give you, given your capital, given your principal, I will give you 3% more of the final good. So everything is accounted in terms of this object. Okay. Now, one important property, of course, when we think about the solutions, there are two different solutions now, but these solutions are the same. Okay, conceptually they are different, but if you calculate the dynamic path, if you calculate the optimal path in this economy, the centralized path is identical to decentralized path. The reason is that there is no public good, there is no externalities, there is no missing market, there is no asymmetric information. So there is no reason in this economy where government intervention makes things better or worse. Okay? So without these things, markets are, so there's basically no market failure, right? Because there's no market failure, social planner's solution is exactly the same with the competitive solution, right? So that's it. Again, now you can change your production function and you can get a different, of course, model. You can introduce depreciation. One thing, let me just show you. You can actually introduce households that are working, right? So this is your, again, objective function. So you want to maximize this. But now your resource constraint may also feature labor income. Okay. So yes, you have assets, but then you can also work for the firms. Now the production function for the firm, or the profit, let me just directly write the profit. The profit could be written simply in this way. Okay. There is this wage cost and there is the cost for, let's say, capital stock, right? You can then extend this model once again with a utility function that that tells you, as consumers, you will also value leisure. Okay, if you have a total of 1 unit of time, you supply LT units to the market for the wage income, and then 1 minus LT units is left for yourself as leisure, right? So you can add other stuff. You can now add a human capital technology to the model, right? You may imagine, instead of capital stock, you may imagine a problem like this. Let's say, again, you want to maximize your intertemporal utility originating from consumption. But now your consumption must obey this budget constraint. Let's say you have this, all right? So what does it tell you? It tells that your consumption must be equal to your wage income plus your human capital stock. So this is your total earning plus out of this. So let me now formulate the problem in this way. So you spend some time, however, for schooling, let's say, or on-the-job training. Okay. So this is your base wage. This is your skill endowment. And this is your labor supply. Okay. So S here is, let's say, on-the-job training. Okay, you have 1 unit of time. You spend S units of it to on-the-job training, and then in the remaining time you work. But now, of course, the problem becomes interesting because on-the-job training allows you to accumulate more skills. Okay, and you can even make this problem a bit more realistic if you introduce skill depreciation, right? So delta H is between 0 and 1. So your skills, your human capital stock, can depreciate in time because of technological progress, because of innovations, etc. Or because of age, when you get older and older. Okay, so as you see, there could be many different problems. Let me show you a firm problem. Suppose that there is a firm, okay? This firm wants to maximize the present value of future profits. Okay? Future profits, and I here is some market interest rate. Okay? So profit now could be defined in this way. There is this price of the good. There is the production function, right? So this is the total revenue from sales, all right? Now, there is this cost for labor, right? And then there is the investment expenditure, okay? And you may actually imagine the investment goods in the economy have a different price level, okay? So I is investment, and here for simplicity, let's assume that investment will be larger than that and smaller than that, okay? You may actually imagine this could be 0, okay? And you can imagine this is less than positive infinity. So why would there a maximum constraint? Well, perhaps because there are some borrowing constraints in the economy, right? So in such a problem, obviously, since this is not general equilibrium, we assume all of these are exogenous, all right? And now the important equation, of course, is the equation that determines the law of motion for capital stock. All right? Now let's solve this problem. This is, by the way, this is from your textbook. This is from Takayama, investment problem. All right, so we can solve this problem, right? How do we solve that? Well, we're going to use the current value Hamiltonian. Right, so I will have the profit here. Profit here is basically this WNT minus PI IT, right? And then I have the current value shadow price. Then I will have the accumulation equation, the transition function, right? So here, what are my control variables? What are the control variables here?
Investment.
Okay. Anything else? What am I going to choose as a firm? Yes, okay, I will choose an investment expenditure. What else? I will also choose a demand for labor, right? I will not choose capital stock, right? I will not be choosing capital stock because capital stock is my state variable. All right. So I have then two control variables, right? So the Hamiltonian, the derivative of Hamiltonian with respect to n, let's suppose that n will be positive and I min is strictly greater than 0, so I will also positive. All right, so we're going to look at the interior solutions. So this will be equal to 0. This will be equal to 0, right? And then we have the constraint itself, right? The constraint itself. And then we have what? We have the co-state equation. Co-state equation is, be careful, your discount rate is I in this model, right? And the derivative of Hamiltonian with respect to KT. So it looks like, so let me start here. So from this, I have P times Fn KT and T equals W, right? From here, I have minus Pi plus Qt equals 0, right? This is just there. And here I have derivative of the Hamiltonian with respect to K. So it's like P, Fk, Kt, and T minus Qt delta, right? So, and I have the transversality condition, right? Transversality condition is limit t goes to positive infinity, Qt e to the minus it, Kt equals 0, right? So now I learned a couple of things from these equations. First, firm's optimal demand for labor reflects your all-time favorite marginal productivity rule, right? So the marginal productivity of labor will be equal to the real wage. Okay, so that's that. Then from this equation, you realize firm will invest, because here we are going to look at an interior solution. Firm will invest and keep the marginal value of the capital stock at the price of investment good. Okay? At the price of the investment good. So in other words, Q dot will be 0, right? Since this is exogenous and constant, Q dot will be equal to 0. All right? So this equation then could be written in this way. This one could be written in this way. 0 minus IQT equals minus P Fk Kt and T, right? Plus Qt delta. Is that correct? Q dot equals 0, IQT equals minus PFK plus Qt delta. Yes. All right. So what does it tell you? What does it show you? I already know Qt will be equal to Pi, right? So this equation solves you what? This equation, first of all, tells you Fk, Kt, and T, right, will be, so P times Fkt and T, Fk, Kt, and T will be equal to what? I plus delta Qt. Is that correct? Yes. So the marginal productivity of capital will be such that here, eventually, if you replace the shadow price, you will obtain the user cost of capital. Okay? This is called the user cost of capital. Now, as you see, it depends on market interest rate, right? It depends on market interest rate. It depends on the depreciation because firm pays for the depreciation here, right? There's no household. It's basically a firm. There's only firm here. So firm should cover the depreciation cost as in reality, right? Then this percentage rate, I plus delta, will be multiplied by the price of investment. Why? Because for each unit of investment, I am paying a price. And then this is nominal cost. On the numerator, you see the nominal cost. And here we divide it by the price level. So this becomes the real user cost of capital. Okay? And obviously, you have two equations, two unknowns. Okay? Now, what happens here? What is the investment expenditure? How do I find the investment expenditure? Okay, I have two equations and two unknowns. Now I can solve them. But how do I find the investment expenditure? Think about it. What is going on here? Now, I didn't have a dynamical system, right? Where is my dynamical system? What happens? This is very intuitive. If you understand this, you understand a lot of economics, my friends. What is going on here? Let me tell you what is going on. If a firm faces a current price for investment and all the other prices are given as well, which is here we are assuming that wages fixed, price of the product is fixed, nominal interest rate is fixed, depreciation is fixed, price of investment is fixed. This then tells the firm, okay, I should directly go to my optimal value, right? Optimal stock of capital, optimal stock of labor, because the real wage does not change. Basically, the real cost of labor, right? The real wage, it is fixed. And the real user cost of capital is also fixed. So I should directly find my desired level of capital stock. I should directly find my desired level of labor. Okay? So at the end of, so using these two equations, you basically solve for K star and star. Okay? Then, what do you have here? Here, K star will be fixed. Okay? K star will be fixed as a function of this stuff, right? PI, etc. If K star is fixed, then K dot is equal to 0. Then this tells you your desired level of investment is equal to delta K star. Okay? Because if you want to sustain that capital stock, you have to still invest, but that investment will be exactly equal to the depreciation. Okay? Now, finally, we should check the transversality constraint. And since this is constant, this is constant, this goes to 0. Okay? And of course, I mean, the second order conditions are satisfied because production function is concave. I mean, we assume that production function is concave, right? So this function is concave. Since this function is concave, this is already linear, so it is concave. Then we have a concave reward function, which is profit here. And then you have the solution. So the dynamic path is something like this. Dynamic path is something like this. Let's say you have these variables here. So initially, let's say you are here. This is your K0. Okay. And this is your K dot equals 0 curve, because it is this, right? Sorry, so it is like this. I'm sorry. So K dot equals I minus delta K. So K dot equals 0 line is this, right? So you have, let's say this. So this is your K dot equals 0, IT equals delta KT curve. Now, initially, you are here, okay? Then you find your K star. Let's say K star is here. So in the first instance, okay, for delta T very close to 0, you jump to K star, and then, so this is a jump. It's just an instant, and then you find your I star here. Okay, so there is no adjustment in this model. No adjustment. No adjustment dynamics. Okay. Now, how to change this model? Well, you can tell me. Price of investment is changing in time. Okay. Now you can do it either exogenously or endogenously, right? If you want to do it endogenously, then you will have another sector or another firm that produces the investment good. Okay? Then that firm, the one that produced the investment good, will have a production function, let's say. Okay? So the investment good will be produced by another production function, let's say, that only uses labor. Okay? Then there will be a profit for this firm. That profit will be this, and then there will be a profit maximization problem solved by this firm, right? And that firm, and IT, of course, okay, that firm will find this optimal level of labor, and then that optimal level will give you this. Then our firm will have a demand for the investment good, and that demand will be equal to the supply. Okay, and then that would be solving the price. And price would still be fixed because there is no technological progress here. So you can actually introduce technological progress to the production of the investment good. Okay, then depending on AT, then PIT would be changing. If AT is going up, price will be going down, and changing price will of course be reflected on the optimal choice of our firm. Okay, so you can populate different ideas and different models. So let me stop here for 3 minutes, and I can answer your questions and comments. We will have more examples, don't worry about it, but for each example, you should see how I am proceeding to solve the problem. Okay? In some problems, the things get rather easier, as you see here, because this is a very simple problem. We are fixing all the prices in the economy. It's a partial equilibrium model. So in this partial equilibrium model, since all the prices are fixed, capital stock and labor demand are fixed, and then the firm will sustain an optimal path by only investing at the depreciation. Okay, you have 2 minutes now.
Can we solve previous problem in the next hour?
Yeah, exactly.
Okay.
We're going to see different types of problems this week and possibly next week as well.
Okay, good.
And in my website, there are many different sample exams and sample homework, so you will see even more problems there. Okay. All right, then let's take another break. Let's meet at 2:40. Is 2:40 okay for everybody?
Okay for me.
It's okay.
All right, 2:40 then. Let's meet at 2:40 for our third session.